Let's look at how we subtract fractions. In order to add or subtract fractions, we want one common denominator. So I'm going to put the LCM down here, and I'm going to go back and factor the denominator. So I write two sets of parentheses for both of those denominators. The factors of that first term in the first denominator are 2x and 3x. The factors of the last term, 3, are 1 and 3. We never put commons together in parentheses because we always factor out what's common first. Then we need to check the signs. They're supposed to be different. The result is supposed to be negative. So negative 3 times 3 is negative 9. Plus 1 times 2 is positive 2 will give you your negative 7x. In the second denominator, your factors of the first term are 3x and 3x. And the factors of the last term are 1 and 1. Again, the signs are different. So to make them different, one's a plus, one's a minus. And since the same thing was in both parentheses, it didn't matter where you put the plus or the minus. So that's the multiplying part. Then we want what's common. I can see that both of them have a 3x plus 1. So I kind of make a little mark there, and I'm going to write that one down just once, 3x plus 1. And looking for anything else common? No. So the L stands for all the leftovers. So I'm going to include the 2x minus 3 and also the 3x minus 1. So that's my LCM, that's my common denominator, but if you notice it's not the same as the denominators in the original problem. So we need to go back and fix these fractions, find out what's missing. This first denominator is missing the 3x minus 1. If I put it in the denominator, I must also put it in the numerator. And the second denominator is missing the 2x minus 3. So if I put that down in the denominator so that my denominators are common, are the same, I must also put that in the numerator, 2x minus 3. Then I go back down here in the new fraction and expand out this numerator. I don't write it down again, I multiply it out. 21x minus 7 minus, and that's very worrisome. I'm going to use a set of parentheses and multiply out what's inside and leave that subtraction there temporarily. So x times 2x is 2x squared, and x times negative 3 is negative 3x. Positive 4 times 2x is positive 8x. And positive 4 times negative 3 is negative 12. So our denominator doesn't change. We can write that down. And we still have our 21x minus 7. But this subtraction needs to get changed to adding the opposite, and it's the opposite of every single thing that follows. But as I write down everything that follows, I'm going to combine like terms as well. So the opposite of positive 2x squared is negative 2x squared. A negative 3x and a positive 8x is 5x, but I need to do the opposite of that, so that's a negative 5x. And a negative 12, doing the opposite of that, is positive 12. So now we can go back and combine like terms again. We have a negative 2x squared. There's only one of those. A positive 21x and a negative 5x makes that a positive 16x. And a negative 7 and a positive 12 makes that a positive 5. So again, we're not quite done with this problem until we know that it doesn't factor. Our factors of 5 are 1 and 5, and the factors of negative 2x squared is a negative 1 and 2, x and x. Well, one of them has to be negative. It could be the 2 or the 1. But any way that I do this multiplying, 5 times 2 is 10 and 1 more is 11, I'm never going to get up to 16. So since the numerator does not factor, the fraction does not reduce, and I'm done with the problem.